And now in this lecture I will answer two questions. In the first question, we'll find out the length of this line segment AQ is equal to x. We have to find out the value of x. And the second question, we'll find out the area of this quarter circle AOB. So we'll start with the first question. In the drawing we have a semicircle, APCB is a semicircle. And we also have here, this is line segment QP, this is equals to 6 units in its length. This is line segment CB, this is equals to 5 units in its length. This is again PQC, that is a right angle. Again, our task is to find out the length of this short line segment AQ, that is equals to x. We have to find out the value of x. AB is of course the diameter of this semicircle, and this is peripheral angle ACB. That's some stand on chord AB, that is the diameter of this semicircle. So therefore we can implement here rule 7. So I repeat quickly on rule 7. According to rule 7, if a peripheral angle subtends on the diameter of the circle or semicircle, then it is equal to 90 degrees in its size. So in the drawing we have a circle. This is peripheral angle ACB. That's subtend on chord AB. That is the diameter of this circle. And therefore peripheral angle ACB equals to 90 degrees in its size. So according to this rule 7, any peripheral angle that equals to 90 degrees in its size must any peripheral angle that subtend on the diameter of the circle or semicircle must be equal to 90 degrees in its size. So we can implement rule 7 in our drawing. Well, in our drawing, this is peripheral angle ACB. That's subtend on AB, that is the diameter of this semicircle, and therefore peripheral angle ACB must be equal to 90 degrees in its size. So AB is the diameter of this semicircle, so this is known. It is given us the question that this is arc AP is equal to this arc CB in its length. And because of the fact that those two arcs are equal to each other in their lengths, their corresponding chords must be also equal to each other in their lengths. The corresponding chord of this arc CB is chord CB, and the corresponding chord of this arc AP is arc AP. So we join points A and P together by straight line. So we can implement here rule 56. According to rule 56, if two arcs are equal in length, then their corresponding chords are also equal to each other in their lengths. So in the drawing we have a circle. This is arc AB. This is equal to this arc CD in its length. So those two arcs are equal to each other in their lengths. And therefore, according to this rule 56, their corresponding chords must be also equal to each other in their lengths. The corresponding chord of arc AB is chord AB, and the corresponding chord of arc CD is chord CD. So the two corresponding chords must be equal to each other in their lengths. That is to say, arc AB equals to arc CD in its length. Chord AB equals to chord CD in its length. Okay. Again, if arc AB equals to arc CD, then their corresponding chords must be also equal to each other in their lengths. That is to say, chord AB equals to chord CD in its length. So we can implement rule 56 in our drawing. In our drawing, it is given us the question that arc AP equals to arc CB in its length, and therefore their corresponding chords must be also equal to each other in their lengths. That is to say, chord CB equals to chord PA in its length according to Rule 56. So until now, I actually found out that chord CB equals to chord AP in its length according to Rule 56. But it is given us a question that chord CB equals to 5 units in its length. So we can write here that CB equals to 5. And from this equation, 5 equals to CB equals to PA. We will derive that chord PA also equals to 5 units in its length. E equals to 5. This is chord PA. This equals to 5 units in its length. According to Rule 56. In the next step, we will join points P and C together by a straight line. So again, we will join points C and B together by a straight line. By joining points P and C, we can do triangle PCA. This is triangle PCA. Triangle PCA subset on arc AP. This is equals to 5 units in its length. Likewise, we have another triangle. This is triangle ACB. Triangle ACB. Subset on chord CB, this is also equals to 5 units in its length. So those two triangles subtend on equal chords. This is equals to 5 units in its length, and therefore they must be equal to each other in their sizes, according to Rule 57. So repeat quickly on Rule 57. According to Rule 57, if two triangles subtend on equal chords, then they are equal to each other in their sizes. So in the drawing, we have a circle. This is chord AB. This is equals to chord EF in its length. Again, AB equals to EF. This is triangle ACB. This is equals to alpha degrees in its size, and it's subtend on chord AB. Likewise, this is triangle ADF. This is equals to beta degrees in size, and it's subtend on chord EF. And because of the fact that those two triangles subtend on equal chords, that is to say chord EF equals to chord AB, they must be equal to each other in their sizes. That is to say, triangle ACB equals to triangle EDF in its size, or alpha equals to beta. Okay, so we can implement Rule 57 in our drawing. In our drawing, this is triangle PCA that subtend on this chord called PA. This equals to 5 units in its length. Likewise, this is triangle ACB that subtend on this chord CB. This is also equals to 5 units in its length. And because of the fact that those two triangles that subtend on equal chords, this is equals to 5 units, they must be equal to each other in their sizes. This is to say, triangle PCA is equal to triangle CAB in its size, according to Rule 57. So triangle PCA is equal to this triangle BAC in its length, because of the fact that they are both subtend on equal chords. AP equals to CB equals to 5. So according to Rule 57, triangle PCA equals to triangle BAC. So if we define the size of this perifungal, PCA, this angle is alpha. From this equation, we will derive that perifungal BAC must be also equal to alpha degrees in its size. Perifungal BAC also equals to alpha degrees in its size. This is perifungal BAC. This also equals to alpha degrees in its size. So in this right triangle PQC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. So this third missing angle must be equal to 90 degrees minus alpha in its size. Likewise, according to the sum rule, in this right lower triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha in its size. According to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. Therefore this first angle must be equal to 90 degrees minus alpha, 90 degrees minus alpha in its size. It's very easy to see that this is the right triangle, PQC. This right triangle PQC is similar to this right lower triangle ACB. So write those two adjacent triangles are similar to each other. First of all, those two angles are both equal to 90 degrees and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to alpha and therefore they are equal to each other. So if you found out that all the figures of this right triangle PQC are corresponding equal to all the figures of this right lower triangle ACB, and therefore those two right triangles are similar to each other according to angle similarity rule. So I'll write it down. We actually found out that this is the right green triangle PCQ. And it's similar. This is the sign of similar to this right lower triangle ACB or ABC according to angle similarity rule. Repeat again, actually found out that the right green triangle PCQ is similar to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC over side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC over side AC of this right lower triangle ABC. So I'll write it down. PQ over CB equals to QC over AC. Again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of the green triangle over side CB of the lower triangle ABC is equal to side QC of the green triangle over side AC of the lower triangle ABC. PQ is the missing side, so we leave it as it is, over CB. CB equals to 5, and it is equals to QC. QC is 6, according to what is given in the question, over AC. AC in total equals to AQ, that is x, plus QC, that is 6. So in total, AC equals to x plus 6 units in its length. So in total, we found out that PQ over 5 equals to 6 over x plus 6. Here we will cross multiply this equation, and finally we get that 5 times 6 is 30, equals to, actually we can, 5 times 6 is 30, equals to PQ times x plus 6. So 30 equals to PQ times x plus 6. Here we divide this equation by x plus 6. And we get that the missing side PQ is equal to 30 over x plus 6 units in its length. So actually we found out that this is the missing side PQ, this equals to 30 over x plus 6 units in its length. PQ equals to 30 over x plus 6 units in its length. AQ is the missing answer that we are looking for in this question. AC is a straight line, according to what is given as the question. If we focus on the upper side of the straight line AC at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q? We have this angle, that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, triangle APQ is the right angle. Triangle APQ is the right angle. So, in the next step, we will implement the Pythagoras theorem on this right triangle AQP. Here by PT is the relation for Pythagoras theorem. This right triangle AQP, according to the Pythagoras theorem, PA squared, that is the square of the hypotenuse, equals to PQ squared plus QA squared. Okay, again, in this right triangle AQP, according to the Pythagoras theorem, states that the sum of the, according to the Pythagoras theorem, the sum, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Because again, according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And therefore, in this right triangle AQP, according to the Pythagoras theorem, PA squared, this is the square of the hypotenuse, equals to PQ squared plus QA squared. PA is 5, and therefore PA squared is 5 squared, this is 25. And it is equals to PQ squared. PQ equals to 30 over x plus 6, and therefore PQ squared equals to 30 over x plus 6 squared. Plus QA squared. QA is the missing 97 that we are looking for in this question. So QA equals to x, and therefore QA squared equals to x squared. So in total, we found out that in the right triangle AQP, according to the Pythagoras theorem, 25 equals to 30 over x plus 6 squared plus x squared. So 25 equals to 30 over x plus 6 squared. This is actually 30 squared, this is 900 over x plus 6 squared plus x squared. So 25 equals to 900 plus x plus 6 squared plus x squared. Here we will multiply x squared by x plus 6 squared, and then we will divide it by x plus 6 squared in order to come factor with this number. So here we have 900 over x plus 6 squared, and we will multiply x squared by x plus 6 squared. Then we divide it by x plus 6 squared. So in total, we have found out that $25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. Here we will multiply this equation by x plus 6 squared. And you get that $25 times x plus 6 squared equals to 900 plus x squared times x plus 6 squared. Here we will open the brackets on both sides of this equation and get that first of all we have to find out what is the value of x plus 6 squared, and then we will open the brackets. So it is 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. And it is equals to 900, and x plus 6 squared equals to x squared plus 36 plus 12x. Now we will open the brackets on both sides of this equation and we get that 25 times x squared equals to 25 times 36 is 900, so it is plus 900, and 25 times 12x is plus 300x. And it is equals to, we'll open the brackets on this side of the equation, so 900 times x squared is 900x squared. And we have here, well, actually, it's not multiplication, but we have to add 900, it's plus. So here is 900 times x plus 6 squared times x squared. So we have here 900 plus x squared times x squared is x to the power of 4, and x squared times 36 is 36x squared, and 12x times x squared is 12 cubed. So in total we found out that 25x squared plus 900 plus 300x equals to 900 plus x to the power of 4 plus 36x squared plus 12 cubed, 12x cubed. Here we have 900 of both sides of this equation, so 900 will get cancelled. After we cancel 900, in this side of the equation we left only with 25x squared plus 300x equals to x to the power of 4 plus 36x squared plus 12x cubed. So here we will subtract 25x squared from this equation, and we get that 300x equals to x to the power of 4 plus 36x squared. 36x squared plus 25x squared is 11x squared. Plus 12x cubed. So in total we found out that 300x equals to x to the power of 4 plus 11x squared plus 12x cubed. Here we will subtract 300x from this equation, and finally get that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So in total we found out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. Here we take x as a common factor from those long expressions. So what is left from x to the power 4 after we took from it x as a common factor? What is left is actually x cubed plus what is left from 12x cubed after we took from it x as a common factor. What is left is actually 12x squared plus what is left from 11x squared after we took from it x as a common factor. What is left is actually 11x, and what is left from minus 300x after we took from it x as a common factor. What is left is actually minus 300 equals to 0. Okay, again, in total we found out that x times x cubed plus 12x squared plus 11x minus 300 equals to 0. Here we have two solutions that are possible for this equation. Either x equals to 0. If x equals to 0, then you get that 0 times anything is 0. So 0 equals to 0. So that is the first solution for this equation. And the second solution for this equation is that x squared plus 12x cubed plus 12x squared plus 11x minus 300 equals to 0. So if this expression equals to 0, then 0 times anything is 0, and 0 equals to 0. But because of the fact that x is the length of this last element AQ, so x as a length, it must be a positive number, and therefore can even be equal to 0. That's it. not a positive number. So the first solution for x is the incorrect solution. X can never be equal to 0 because x is a length. And therefore we left only with the other possibility for the value of x, that x squared, x cubed plus 12x squared plus 11x minus 300 equals to 0. So here we can try to guess that the x equals to 3. So if x equals to 3, then the value of this expression in total is equal to x cubed. If x is 3, then x cubed must be equal to 3 to the power of 3, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9. 9 times 12 is 108. Plus 11x. X is 3, therefore 11x is 11 times 3, that is 33, minus 300 equals to 0. But 27 plus 108 plus 33, in total it is 168 minus 300. 168 minus 300 is definitely not equal to 0. And because of the fact that for x equals to 3, this equation is not true. So x can never be equal to 3 because we don't get here 0 equals to 0. So x can never be equal to 3, so we cancel this possibility, and then we check if x can be equal to 4. If x can be equal to 4, then we get that this equation is true for x equals to 4. So if x equals to 4, then the value of this expression, x squared is 4 to the power of 3, that is actually 64, plus 12x squared. X is 4, so x squared is 4 squared, that is 16, and 16 times 12 is 192, plus 11x. X is 4, so 11x is 11 times 4, that is 44, minus 300. Is it equal to 0 or not? First of all, 34 plus 63 is 108. 108 plus 192 minus 300 equals to 0. Okay, so 108 plus 192 is 300, and 300 minus 300 is 0. So we found out that if x equals to 4, then this equation is true. And therefore, the value of this expression, that is to say, x cubed plus 12x squared plus 11x minus 300, this expression is equal to x minus 4 times x squared plus 16x plus 75. Repeat again. This expression, that is to say x cubed plus 12x squared plus 11x minus 300 equals to this expression. Those two expressions are identical. So this expression in total equals to x minus 4 times x squared plus 16x plus 75. You can actually open the brackets and we'll find out that those two sides of the equation are equal to each other. So we have to solve this equation, and we know that this expression equals to 0. and those two expressions are equal to each other, and therefore this expression must be equal to 0. So this, that is to say, x minus 4 times x squared plus 16x plus 75 is equal to 0. Again, this expression equals to 0, and those two expressions are identical, and therefore this expression must be also equal to 0. So, what is the solution of this expression? Either x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything is 0. So this equation is true if x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything is 0. So 0 equals to 0. And the second solution for this equation is that this expression equals to 0. So x squared plus 16x plus 75 is equal to 0. If this expression equals to 0, then 0 times anything is 0, and we get that 0 equals to 0. So we have two possible solutions for this equation. If x minus 4 equals to 0, then x equals to 4. So the first solution for this equation is that x equals to 4. That is to say, the length of this line segment AQ equals to x is equal to 4 units. And the second solution is that this expression, this quadratic equation, equals to 0. Actually, what we have here, we have x squared plus 16x plus 75. We'll substitute 75 by 64 plus 11 equals to 0. X squared plus 16x plus 64 is actually equals to x minus 8 squared. If you open the brackets of x minus x squared, you get that x minus 8 squared equals to x squared plus 16x plus 64, and we have a plus 11 is equal to 0. So here we will subtract 11 from this equation, and finally get that x minus 8 squared is equal to 0 minus 11 is minus 11. So we found out that x minus 8 squared equals to minus 11. X is a positive number. Anyway, x minus 8 squared, x minus 8 squared, it is definitely a positive number. Okay, and it can never be equal to minus 11, that is a negative number. A positive number can never be equal to a negative number, and therefore this solution is an incorrect solution. Okay, this solution is an incorrect solution, and the only solution that is left for x, that is x equals to 4. This is line segment AQ equals to x, and x equals to 4 units in its length. Okay, so we finish with the first question. The next step, I present you the second question and solve the second question of this lecture. By the way, x can never be equal to 8. If x equals to 8, then 8 minus 8 is 0. But x can never be equal to 8, or x can never be equal to 8, because in this right line AQP, the hypotenuse PA equals to 5. If the hypotenuse PA equals to 5, it means that x must be less than the hypotenuse. So x can never be equal to 8, and therefore it means that x minus 8 squared must be a positive number. and a positive number can never be equal to a negative number, and therefore this solution is the incorrect solution, and we have to only, the only solution that is for x, that x equals to 4, aq equals to x, and x equals to 4 units in itself. In the second question, our task is to find out the area of this quarter circle AOB. Okay, so in the moment we have quarter circle AOB. This is line segment PQ, this equals to 4 units in itself. This is line segment AQ, this equals to 4 units in itself. This is angle PQA, that is a right angle. Again, our task is to find out the area of this quarter circle AOB. First of all, OA equals to OB. They are both the radii of this quarter circle, and therefore they are equal to each other. So if we define the radius of this quarter circle as R, then the radius OA equals to R. And the radius OB must be also equal to R units in its length. This is the right triangle AOB. AOB, in the right triangle AOB, side BO equals to side AO. They are both the radii of the quarter circle. This equals to R, and therefore they are equal to each other. And we have the rule that says that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes. So if we define the size of this angle as x, then the size of this angle must be also equal to x degrees because they are equal to each other. In the next step, we'll focus on this right triangle, triangle ABO. In the right triangle ABO, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle ABO? X plus x is 2x plus 90 degrees. 2x plus 90 degrees. In total, they must be equal to 180 degrees according to the rule that says that the sum of the angles in the triangle is equal to 180 degrees. Repeat again. In the right triangle BOA, the sum of the angles must be equal to 180 degrees. That is to say, 2x plus 90 degrees equals to 180 degrees. Here we subtract 90 degrees from this equation. And we get that 2x equals to 180 degrees minus 90 degrees is 90 degrees. So 2x equals to 90 degrees. Here we will divide this equation by 2 and finally get that the missing angle x is equal to 90 degrees over 2, that is 45 degrees in its size. Okay, this is the missing angle x. That goes to 45 degrees in its size. Likewise, this is the missing angle x. This goes to 45 degrees in its size. So the right triangle AOB is also an associated triangle. In the next step, we will do a construction. That is to say, from point O, we will draw perpendicular on AB. Again, from point O, we will draw perpendicular on AB. So this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We will define the touching point of the perpendicular from point O and AB. This point is point M. In the next step, we will focus on this right triangle AMO. In the right triangle AMO, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AMO? We have 90 degrees plus 45 degrees. Plus this missing angle AOM. In total, they must be equal to 180 degrees according to the rule that states that the sum of the angles in any triangle is equal to 180 degrees. If again the right triangle AOM, the sum of the angles must be equal to 180 degrees. That is to say 90 degrees plus 45 degrees plus the missing angle AOM in total must be equal to 180 degrees. 90 degrees plus 45 degrees is 135 degrees. So 135 degrees plus the missing angle AOM in total must be equal to 180 degrees. Here we subtract 145 degrees from this equation and find out that the missing angle AOM is equal to 180 degrees minus 135 degrees is 45 degrees. So actually this is the missing angle AOM. This equals 45 degrees in its size. We have another rule that says that in front of equal angles in the triangle there are equal sides. So in the right triangle AOM, in front of those two equal angles, we have those two sides that must be also equal to each other and their lengths. That is to say, side AM equals to side MO. According to the rule that I mentioned, in the right triangle AMO, side AM must be equal to side MO in its length. Again, in the right triangle AMO, according to the rule that I mentioned, side AM equals to side MO. But side AM in total equals to AQ plus QM. We define the length of line segment QM as X, and therefore in total AM equals to 4 plus X. So we can write here that AM equals to 4 plus X. And for this equation, 4 plus X equals to AM equals to MO, we will derive that the side MO must be also equal to X plus 4 units in its length. This is the missing side MO that must be also equal to X plus 4 units in its length. In the next step, we will do another construction. That is to say, we will do perpendicular on line segment PQ at point P. Again, we will do perpendicular on this short line segment PQ at point P. So actually, this angle equals to 90 degrees inside according to our construction. In the next step, we will extend the perpendicular OM by straight line until it touches the extended line P, the extended perpendicular from point P. And we define the touching point of the extended line segment OM with the perpendicular from point P. This point is point N. AB, it is absolutely a straight line according to what is given as the question. So if you focus on the upper side of, if you focus on the left side of the straight line AB at point M, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the left side of the straight line AB at point M? We have this angle that is right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. All three says that the sum of the angles from one side of the straight line is equal to 180 degrees. And therefore, this missing angle must be equal to 90 degrees in its size. Actually, this is the missing angle. So if you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the right side of the straight, which angles we have at the upper side of the straight line AB at point Q? We have this angle that is right angle plus this missing angle in total must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, OM is a straight line. When you extend the straight line by straight line, the result ON must be also a straight line. So ON is a straight line. So if you focus on the right side of the straight line, or in the upper side of the straight line ON at point M, here the sum of the S must be equal to 180 degrees according to all three. So which angles we have at the lower side of the straight line OM at point M? We have this angle is equal to 90 degrees. Plus this is missing angle in total must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So in total, in quadrilateral NMQP, we have three right angles. The sum of three right angles is 270 degrees. So in quadrilateral MNPQ, we have three right angles. The sum of three right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, the triangle P and M. In total, they must be equal to 360 degrees. According to the rule, it says that the sum of the angles in any quadrilateral is equal to 360 degrees. This is the missing angle P and M. So in total, the sum of the four angles must be equal to 360 degrees according to the rule that I mentioned. Here we subtract 270 degrees from this equation and find out that the missing angle P and M is equal to 360 degrees over 270 degrees is 90 degrees. So actually, this is the missing angle P and M. This is equal to 90 degrees in size. So in quadrilateral NMQP, we have four right angles, and therefore we can relate to quadrilateral PNQP as a right angle. But we also know that the opposite sides of a right angle are equal to each other. So in this right angle NMQP, side QM must be equal to the opposite side Pn, but QM is x, and therefore the opposite side Pn must be also equal to x units in its length. Likewise, according to the sum rule, in the same rectangle NMPQ, side PQ must be equal to the opposite side NM, but PQ equals to 3 units in its length, according to what is given as the question, and therefore the opposite side NM must be also equal to 3 units in its length. In the next step, we'll join points O and P together by straight line. By joining points O and P, we get the triangle OPN. Point O is the center of this circle, point P is the point on the circle itself, therefore OP is the radius of the circle. What is the radius of the circle? OA is also the radius of the circle. But again, in quarter circle AOB, OB and OA are both the radius of the circle. So first of all, we will find out the length of the radius of this circle by implementing the Pythagoras theorem on this right triangle AMO. Okay, again, we'll find out the length of the radius AO of the quarter circle by implementing the Pythagoras theorem on this right triangle AMO. In the right triangle AMO, here by PT is the abbreviation for Pythagoras theorem. So in this right triangle AMO, AO squared, that is the square of the hypotenuse, equals to MO squared plus MA squared. Again, in this right triangle AMO, according to the Pythagoras theorem, AO squared, that is the square of the hypotenuse, equals to MO squared plus MA squared. AO is the missing hypotenuse, so we leave it as it is. So it is AO squared equals to MO squared. MO is x plus 4, and therefore MO squared is x plus 4 squared. Plus MA squared. MA is also x plus 4 because it is an isosceles in the right triangle at the same time. So MA is also equals to x plus 4, and therefore MA squared must be equal to x plus 4 squared. So in total, we found out that in the right triangle AMO, AO squared, that is the square of the hypotenuse, equals to x plus 4 squared plus x plus 4 squared. So AO squared equals to x plus 4 squared plus x plus 4 squared is 2 times x plus 4 squared. Here we take root out of this equation and find that the missing hypotenuse AO is equal to the square root of 2, and the square root of x plus 4 squared is x plus 4. So the missing hypotenuse AO equals to square root of 2 times x plus 4 units in its length. The hypotenuse AO is also the radius of this circle. That equals to the square root of 2 times x plus 4 units in its length. Repeat again, point O is the center of the quarter circle, point P is the point of the quarter circle itself, therefore OP is the radius of this quarter circle. We just find out that the radius of this quarter circle equals to the square root of 2 times x plus 4 units in its length. Now we can definitely implement the Pythagoras theorem on this right triangle OPM. Therefore OP equals to square root of 2 times x plus 4 units in its length. Side PN equals to x, and side ON in total equals to x plus 4 plus 3. So x plus 4 plus 3 is x plus 7. So we implement the Pythagoras theorem on this right triangle ONP. Here by PT is the abbreviation for Pythagoras theorem. In this right triangle ONP, OP squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. But again, in this right triangle PNO, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. We just right now found out that the hypotenuse PO, that's actually the radius of the quarter circle, is equal to the square root of 2 times x plus 4, and therefore the square of the hypotenuse is equal to the square root of 2 times x plus 4 squared. And it is equal to Pn squared. Pn is x, therefore Pn squared is x squared plus NO squared. NO in total equals to x plus 4 plus 3. It is x plus 7. And therefore NO squared in total must be equal to x plus 7 squared. So in total we should find out that the square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. We'll open the brackets of this expression. Square root of 2 squared is 2. And we have x plus 4 squared. So total this expression equals to 2 times x plus 4 squared. And it is equal to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is plus 14x. Here we open the brackets on this side of this equation, and we get that 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is plus 8x. And it is equal to x squared plus x squared is 2x squared plus 49 plus 14x. Here we subtract 14x from this equation. Actually, here x plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. So here we will open the brackets of this expression. We will have 2 times x squared is 2x squared plus 2 times 16 is 32, so it is plus 32, plus 2 times 8x is 16x. Yes, and it is equals to 2x squared plus 49 plus 14x. Here we have 2x squared on both sides of this equation, so 2x squared get cancelled. And we subtract 14x from this equation, and we get that 16x minus 14x is 2x, and so here those two expressions get cancelled, and we subtract 32 from this equation. So 32 minus 32 is 0, so in this equation we left only with 2x, and here we have 49 minus 32 is 17. So total we found out that 2x equals to 17. Here we will divide this equation by 2 and find out that x equals to 17 halves. X equals to 17 halves. Our task is to find out the area of this quarter circle. So the area of this quarter circle must be equal to the area of the circle over 4. Why? Because the quarter circle is a fourth of the circle. The area of the circle is pi x squared, and therefore the area of the quarter circle must be equal to pi x squared over 4. So the area of this quarter circle AOB the area of the quarter circle AOB equals to pi times r squared, that is the area of the circle, over 4, because it is 4 for of a quarter, it is the 4 for 1/4 of a circle. The area of the circle is pi r squared, and therefore the area of the quarter circle must be equal to pi r squared over 4. So it is pi over 4 times r. The radius of this circle equals to AO. AO is the radius of this circle. So we substitute r by AO. If r is AO, then r squared is AO squared. So in total, the area of this quarter circle AOB equals to pi over 4 times AO squared. AO equals to the square root of 2 times x plus 4. It is the radius. So it is the square root of 2 times x plus 4. So it is pi over 4 times AO squared. AO is square root of 2 times x plus 4, and therefore AO squared equals to the square root of 2 times x plus 4 squared. So we have to square all the expression of AO. So it is pi over 4 times square root of 2 times x plus 4 squared. We will open the brackets of this expression. We get that square root of 2 squared is 2, and we have x plus 4 squared. So in total, we should find out that the area of this quarter circle AOB equals to 2 pi over 4 times x plus 4 squared. So we have we divide this 2 over 4 is 1/2. So it is pi over 2 times x plus 4 squared. But we already found out that x equals to 17/2. So we substitute x by 17/2. We get the area of the quarter circle in total equals to pi over 2 times x is 17/2. Substitute x by 17/2 plus 4 squared. So the area of the quarter circle AOB in total equals to pi over 2, and we have 17/2. We multiply 4 by 2, and then we divide it by 2 in order to come factor with this number. So 4 times 2 is 8 over 2. So the area of the quarter circle in total equals to pi over 2, and in the brackets we have 17 plus 8 is 25. What squared, of course? 25 over 2 squared. So it is pi over 2. 25 squared is 625. Over 2 squared is this is 4. So total the area of the quarter circle equals to, we have here 625 pi. The denominator we have 4 times 2, that is 8. So total we found out that the area of this quarter circle, that is the area of that we're looking for, the area of this quarter circle AOB equals in total to either 625 pi over 8 square root in size, or in terms of numbers, the area of this quarter circle in total it is equal to 245.437 square meters in size. Repeating again, we should find out that the area that we are looking for this question, that is the area of this quarter circle AOB. In total, it is equal to either 625 pi over 8 square meters in size, or in terms of numbers, the area of this quarter circle equals to 245.437 square meters in size. So we finish with the second question. In the next step, I have some other direction. So that is to say, repeat on the solution of the first question, and then we repeat on the solution of this second question. The first question, our task was to find out the length of this line segment AP is equal to x. We have to find out the value of x. So in the drawing we have semicircle APCB. We know that this is line segment QP is equals to 6 units in its length. This is line segment CB or chord CB. This is equals to 5 units in its length. This is again PQA, this is again PQA, this is a right angle. In addition, you know that this is arc CB, this is equals to arc PA in its length. Those two arcs, PA and CB, they are equal to each other in their lengths. Again, our test is to find out the length of this short line segment AQ is equals to x. We have to find out the value of x. So first of all, we implemented all 7 in our drawing. AB is of course the diameter of this semicircle. This is triangle ACB. Triangle ACB subtend on AB, this is the diameter of this semicircle, and we know that any triangle that subtend on the diameter of the semicircle or circle must be equal to 90 degrees in its size. Therefore, triangle ACB that subtend on the diameter of this semicircle AB must be equal to 90 degrees in its size. Here we can also implement all 56 in our drawing. Those two chords, those two arcs, arc PA and arc CB, they are equal to each other in their lengths. And according to all 56, if two arcs are equal to each other in their lengths, then their corresponding chords must be also equal to each other in their lengths. The corresponding chord of arc PA is chord PA, and the corresponding chord of arc CB is chord CB. And therefore, because of the fact that arc PA equals to arc CB in its length, their corresponding chords must be also equal to each other in their lengths. That is to say, PA equals to CB, or chord PA equals to chord CB in its length according to all 56. And again, according to all 56, chord CB equals to chord PA in its length, but it's given in the question that chord CB equals to 5, so I can argue that CB equals to 5, and from this equation 5 equals to CB equals to PA, we will derive that chord PA must be also equal to 5 units in its length. This is chord PA, this is also equals to 5 units in its length. In the next step, we join points P and C together by a straight line. By joining points P and C, we can do triangle PCA. Triangle PCA, subset of chord PA. Likewise, we have also here triangle BAC. This is triangle BAC. That's subset of chord CB. This also equals to 5 units in its length. And because of the fact that those two triangles subset on equal chords equals to 5 units in its length, they must be equal to each other, and their sizes according to rule 57. So if we define the size of this triangle PCA as alpha, then the size of this triangle BAC must be also equal to alpha because they are equal to each other according to rule 57. So in this case, I find PQA, this angle equals to alpha, this angle equals to 90 degrees, and therefore this previous angle must be equal to 90 degrees minus alpha. 1 plus 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in a triangle. Likewise, this right lower triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this previous angle must be equal to 90 degrees minus alpha according to the sum rule that says that the sum of the angles in a triangle is equal to 180 degrees. It is very easy to see that the green right triangle PQC is similar to this right lower triangle ACB, according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So actually prove that all the figures of this green right triangle PQC are corresponding equal to all the figures of this big right triangle ABC, and therefore those two right triangles are similar to each other according to angle similarity rule. So repeat again, if you found out that the right green triangle PCQ is similar, this is the sign of similar, to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PB actually this is side PQ of the green right triangle PQC, this green right triangle PQC, side PQ over side CB of this right lower triangle ABC is equal to side QC of this right triangle PQC over side AC of this right lower triangle ABC. And again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side PQ of the green triangle over side CB of the right lower triangle equals to side QC of the green triangle over side AC of the right lower triangle. PQ is the missing side, so leave it as it is. CB is 5, QC is 6, AC equals to x plus 6. AC in total equals to AQ, that is x, plus QC, that is 6. So in total, AC equals to x plus 6 units in its length. So in total, we found out that PQ over 5 equals to 6 over x plus 6. Here we cross multiply the equation and found out that 6 times 5 is 30, is equals to PQ times x plus 6 units. PQ times x plus 6. Here we divided the equation by x plus 6 and finally found out that the missing side PQ equals to 30 over x plus 6 units in its length. This is the missing side PQ, this is equals to 30 over x plus 6 units in its length. AC is a chord on this semicircle, and therefore it is absolutely a straight line. So if you focus on the upper side of the straight line AC point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC point Q? We have this angle that is right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to Rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in the next step, we implemented the Pythagoras theorem on this right triangle APQ. In the right triangle APQ, according to the Pythagoras theorem, AP squared, this is the square of the hypotenuse, equals to PQ squared plus QA squared. And again, in the right small triangle APQ, according to the Pythagoras theorem, PA squared, this is the square of the hypotenuse, equals to PQ squared plus QA squared. PA is 5, therefore PA squared is 5 squared, that is 25, and it equals to PQ squared. PQ is 30 over x plus 6, and therefore PQ squared equals to 30 over x plus 6 squared, plus AQ squared. AQ is x, therefore AQ squared is x squared. So in total, we actually found out that 25 equals to 30 over x plus 6 squared plus x squared. So 25 equals to, we open the brackets of this expression, we have 30 squared, that is 900, over x plus 6 squared plus x squared. So in total, 25 equals to 900 over x plus 6 squared plus x squared. So here, we multiplied x squared by x plus 6 squared, and then we divided it by x plus 6 squared in order to overcome factor of this expression. So in total, we found out that 25 equals to 900 over x plus 6 squared, and then we multiplied x squared by x plus 6 squared, and then we divided it by x plus 6 squared. So in total, 25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. In the next step, we multiply this equation by x plus 6 squared. And therefore, we found out that we need that 25 times x plus 6 squared equals to 900 plus x squared times x plus 6 squared. So it is 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 46, plus 2 times x times 6, that is 12x. So in total, this expression equals to 25 times x squared plus 36 plus 12x, and it is equal to x squared plus x plus 6 squared. X plus 6 squared equals to x squared plus 36 plus 12x. So here we have 25 times x squared plus 36 plus 12x equals to 900 plus x squared plus 36 plus 12x times x squared. 25 times x squared is 25x squared, and we have 25 times 36 is 900, and we have 25 times 12x is 300x, and it is equals to 900 plus, we have x squared times x squared is x to the power of 4, and we have x squared times 36 is 30 times x squared, and we have x squared times 12x is 12x cubed. So in total, we should all know that 25x squared plus 900 plus 300x equals to 900 plus x to the power of 4 plus 36x plus 12x cubed. So here we have 900 on both sides of this equation. So 900 will get cancelled. 900 will get cancelled. After I cancel 900, in this side of the equation we have to leave 25x squared plus 300x. In the other side of the equation we have x to the power of 4 plus 36x plus 12x cubed. So here we subtract 25x squared from this equation, and I found out that 300x equals to x to the power of 4, and 36x squared minus 25x squared is 11x squared plus 12x cubed. So here we subtracted 300x from this equation, and I found out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. In the next step, we took x as second factor from this expression. Here, the expression is x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So we took x as a common factor from this expression. So inside the brackets we have x cubed plus 12x squared plus 11x minus 300 equals to 0. So we have two possibilities for the value of x in this equation. either x equals to 0 or either this expression equals to 0. So if x equals to 0, then this expression will be equal to 0 times anything is 0, so 0 equals to 0. But the problem is that x can never be equal to 0 because of the fact that x is the length of this line segment AQ. As x is the length, it must be a positive number. So the possibility that x equals to x equals to 0 is incorrect possibility because x is a length and it can never be equal to 0. So we have the other possibility that this expression equals to 0. So 0 times anything is 0, so 0 equals to 0. We solve this equation. So therefore this expression in total equals to 0. That is to say x cubed plus 12x squared plus 11x minus 300 equals to 0. Now we check if x equals to 3, well, if x equals to 3, if this expression is true, when x equals to 3. So we have to substitute x by 3 in order to check if this expression is true for x equals to 3. So if x equals to 3, it means that x cubed is 3 cubed, 3 cubed is 27, plus 12x squared. X is 3, so x squared is 9. 9 times 12 is 108, plus 11x. X is 3, so 11x is 11 times 3, that is 33, minus 300 equals to 0. 27 plus 108 plus 33 is 168 minus 300. 168 minus 300 is definitely not equal to 0. Therefore, x can never be equal to 0. But it doesn't solve this equation. In the next step, we checked if x equals to 4, solve this equation. If x equals to 4, then x cubed is 3 cubed. 3 cubed is 4 times 4 times 4, that is 64, plus 12, 2 times x squared. X is 4, therefore x squared is 16 times 12. 16 times 12 is 192, plus 11x. X is 4, so 11x is 11 times 4, that is 44, minus 300 equals to 0. 64 plus 44 is 108, plus 192. 108 plus 192 is 300, and 300 minus 300 equals to 0. So x equals to 4, solve this equation, and therefore x equals to 4 is a good solution, but we have to check. So in this equation, if x equals to 4, then we get that this equation is true. One, because in total, in this side of the equation, we have 0 and 0 equals to 0. So x equals to 4 is the one solution for this equation. But we have to check whether if this expression equals to 4, it's also for solve this equation, because 0 times anything is 0 and 0 equals to 0. So we check that if x cubed plus 12x squared plus 11x minus 300 equals to 0, then if it's possible. So we have to check that if x cubed plus 12x squared plus 11x minus 300 solve this equation. But this expression is identical to x minus 4 times x squared plus 16x plus 75. If you just open the brackets, you'll find out that this expression is identical to this expression. So we have to check that if x minus 4 times x squared plus 16x plus 75 equals to 0, solve this equation. Why? Because if this expression equals to 0, then 0 times anything is 0 and 0 equals to 0. So we have to check that if this expression equals to 0, solve this equation, but this expression is identical to this expression. So we have to check if this expression equals to 0, whether if the equation is true. Okay, so we have to check that if x minus 4 times x squared plus 16x plus 75 equals to 0, whether if this possibility is correct possibility. First of all, if x minus 4 equals to 0, then 0 times anything is 0, so 0 equals to 0. So if x equals to 4, this equation is true. Okay, but the other possibility is that if this expression x squared plus 16x plus 75 equals to 0, then 0 times anything is 0. But we have to check if this expression, this quadratic equation, can equals to 0, can be equal to 0. Okay, so we have x squared plus 16x plus 75 equals to 0. So x squared plus 16x plus 75. We substitute 75 by 64 plus 11, and therefore this expression in total equals to x squared plus 16x plus 64 plus 11 equals to 0. This quadratic equation, x squared plus 16x plus 64 in total is equal to x minus 8 squared. If we open the brackets of this expression, we get that those two expressions are identical, so x minus 8 squared plus 11 equals to 0. We subtract the 11 from this equation and find out that x minus 8 squared equals to minus 11. X minus 8 squared is a positive number, and the positive number can never be equal to a negative number. So this possibility is the correct solution, and the left one is another possibility that is left from the value of x, that x equals to 4 units in its length. So we should find out that the length of this 978 cubed is equal to x is equal to 4 units in its length. So I finish to repeat on the first solution. In the next step, I repeat on the solution of the second question. In the second question, our task is to find out the area of this quarter circle A or B. Repeat again. Our task is to find out the area of this quarter circle A or B. So we know that this is 970 cubed is equal to 4 units in itself. This is 970 cubed. This is equal to 4 units in itself. This is angle PQ8, this is a right angle. Again, our task is to find out the area of this quarter circle A or B. First of all, OA equals to OB, they're both the radius of the quarter circle, and therefore they are equal to each other. So if you define the radius of this quarter circle as R, then OB equals to R, and the radius OA must be also equal to R. And in the next step, we focus on this right triangle AOB. Right triangle AOB is also an isosceles triangle because side BO equals to side OA. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So in the right triangle AOB, we have the rule that says that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides there are equal angles. Now those two angles that must be also equal to each other in their sizes. So if we define the size of this angle as x, then the size of this angle must be also equal to x because they are equal to each other. And in the right triangle AOB, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AOB? We have x plus x, that is 2x, plus 90 degrees. In total, it must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in the right triangle BOA, 2x plus 90 degrees equals to 180 degrees. Here we subtract the 90 degrees from this equation and find out that 2x is equals to 180 degrees minus 90 degrees is 90 degrees. Here we divided this equation by 2 and found out that the missing angle x equals to 45 units in its length. This is the missing angle x equals to 45 degrees in its size. This is also the missing angle x equals to 45 degrees in its size. In the next step, we did a construction. That is to say, from point O, we draw perpendicular on BA. Again, from point O, that is the center of this quarter circle, we draw perpendicular on BA. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. By doing this construction, you get there, the right triangle AMO. The right triangle AMO, the sum of the ends must be equal to 180 degrees. So which angles we have the right triangle AMO? We have this angle that is 45 degrees, but this angle is 90 degrees, and therefore this angle must be equal to 45 degrees in size. We have also the rule that in front of equal angles in the triangle they are equal size. So in front of those two equal angles, we have those two sides that must be also equal to each other, and they works. That is to say, AM equals to MQ. Again, if you found out that in right triangle AMO, then we say again AM equals to 45 degrees in size, and AM equals to MO. We just I found out that AM equals to MO, because in front of those two equal angles, we have those two sides that are equal to each other. So AM equals to MO, but AM in totality is x plus 4, and therefore MO must be also equal to x plus 4 units in its length. Again, AM is x plus 4, and therefore OM must be also equal to x plus 4 units in its length. This is inside MO, that is equal to x plus 4 units in its length. In the next step, we did another construction. That is to say, we draw perpendicular on this short line segment AQ at point P. Again, we draw perpendicular on this short line segment PQ at point P. So this angle equals to 90 degrees in size according to our construction. Then we extended line segment OM by side line until it touches the perpendicular from point P. The extended perpendicular from point P. We define the touching point of, between the extended line segment OM with the extended perpendicular from point P. This point is point N. By doing this construction, we get the quadrilateral NMQP. In quadrilateral NMQP, this angle equals to 90 degrees according to our construction. And we know that AB is the side line. The sum of the angles on the upper side of the side line AB at point Q must be equal to 180 degrees according to all three. So which angles we have at the upper side of the side line AB at point Q? We have this angle is a right angle plus this missing angle, so that must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in size. Likewise, line segment OM is a straight line. When you extend the straight line by straight line, the result ON is also must be also a straight line. ON is a straight line. So if you focus on the lower side of the straight line OM at point M, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the lower side of the straight line OM at point M? We have this angle as the right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So in total, in quadrilateral PQMN, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction. Those two angles are both equal to 90 degrees according to all three. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, so that must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So in this quadrilateral NMPQ, 270 degrees plus the size of this the fourth missing angle P and M, in total must be equal to 360 degrees. Here we subtract 270 degrees from this equation. If I found out that the missing angle P and M equals to 360 degrees minus 270 degrees is 90 degrees. So this is the missing angle P and M is equal to 90 degrees in its size. So in total, if you found out that in quadrilateral PNMQ, we have 4 angles. And therefore, can I write to quadrilateral PNMQ as a rectangle, because it has 4 angles. But we also know that the opposite sides of rectangle are equal to each other. So rectangle PNMQ, side QM must be equal to the opposite side PN. But QM is x, therefore the opposite side PN must be also equal to x units in its length. Likewise, according to the symbol, when the symbol triangle NMQP, side PQ must be equal to the opposite side NM. But PQ is 3 according to what is in the equation, therefore the opposite side NM must be also equal to 4 units in its length. In the next step, we join points O and P together by a straight line. But before that, we implemented the Pythagoras theorem on this right line AMO. This right line AMO, AO squared is the square of the hypotenuse, equals to AM squared plus MO squared. And again, in the right line AMO, AO squared is the square of the hypotenuse, equals to MO squared plus AM squared. AO is the missing side, so it is AO squared equals to MO squared. MO equals to MO, and each side equals to x plus 4. So MO is x plus 4, and therefore MO squared is x plus 4 squared, plus AM squared, and it's also x plus 4 squared. So in total, if you want to know that AO squared equals to x plus 4 squared, plus x plus 4 squared, it is 2 times x plus 4 squared. So AO squared equals to 2 times x plus 4 squared. Here we took out of the equation and found out that the missing sign AO, the missing opposite AO equals to the square root of 2, and the square root of x plus 4 squared is x plus 4. So in total, the length of the hypotenuse AO, that is actually the radius of the quarter circle, is equal to square root of 2 times x plus 4 units in its length. This is the hypotenuse AO. This is also the radius of the quarter circle, and it is equal to the square root of 2 times x plus 4 units in its length. In the next step, we join points on P together by a straight line. Point O is the center of this quarter circle, point P is the point of the quarter circle itself, therefore OP is the radius of this quarter circle. We just write down found out that the radius of the quarter circle equals to the square root of 2 times x plus 4 units in its length. In the next step, we implement the Pythagoras theorem on this right line OMP. In right line OMP, OP squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. But again, in this right line OPN, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. OP is square root of 2 times x plus 4, and therefore OP squared is square root of 2 times x plus 4 squared, and it is equals to PN squared. PN is x, therefore PN squared is x squared plus ON squared. ON in total equals to x plus 4 plus 3, that is x plus 7, and therefore ON squared equals to x plus 7 squared. So in total, we should now know that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. So here we open the brackets here, and square root of 2 squared is 2, and we have x plus 4 squared. And it equals to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is 14x. We open the brackets of this expression. So we have 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. And it is equals to x squared plus x squared is 2x squared plus 49 plus 14x. We open the brackets of this expression, so 2 times x squared is 2x squared, plus 2 times 16 is 32, plus 2 times 8x is 16x, and it equals to 2x squared plus 49 plus 14x. We have 2x squared on both sides of this equation, so 2x squared we cancel, so cancel 2x squared. We have to only with 32 plus 16x equals to 49 plus 14x. Here we subtracted 14x from this equation, and found out that 16x minus 14x is 2x, 14x minus 14x is 0, and then we subtract 42 from this equation. So 32 minus 42 is 0, and 49 minus 42 is 17. So in total we found out that 2x equals to 17. Here we divided the equation by 2 and found out that x equals to 17 halves. X, this is 97 PQ is equal to 97 QM is equal to x is equal to 17 halves. Our test is to find out the area of this quarter circle AOB. The area of any quarter circle equals to the area of the circle over 4, because it is fourth of the area of the circle. The area of the circle is pi square, and therefore the area of the quarter circle must be equal to pi square over 4. R is AO, R is AO. Therefore, r squared is AO squared. So total the area of this quarter second AOB must be equal to pi times the AO squared over 4. So it is pi over 4, and the radius AO equals to square root of 2 times x plus 4 squared. So it is equals to pi over 4, and we have here square root of 2 squared is 2, and we have x plus 4 squared. So total the area of the quarter second AOB equals to pi over 4 times 2 times x plus 4 squared. 2 over 4 is 1 half, and here we have x plus 4 squared. So in total, the area of the quarter second must be equal to pi over 2 times x plus 4 squared. So it is pi over 2, and we substitute x by 17 halves, x equals to 17 halves. So in total, the area of the quarter second must be equal to pi over 2 plus 17 halves plus 4 squared. So it is pi over 2, and we have here 17 halves plus 4. Here we multiply 4 by 2 and then we divide it by 2 in order to become comfortable with this number. So this pi over 2 times 17 halves, and we have 4 times 2 is 8 divided by 8. We divide it by 2. So we multiply it by 2 and then we divide it by 2, so we change nothing. So total the area of the quarter second must be equal to pi over 2 plus 17 plus 8 over 2. 17 plus 8 is 25, and we have 2 squared is 4. So in total, in the numerator we have 25 pi squared, 25 half squared. 25 squared is 625, so in total, in the numerator of this expression we have 625. We have 2 squared is 4, so in total, in the numerator we have 2 times 4. 2 times 4 is 8, so in total, the other quarter second, AOB equals to 625 pi over 8. In terms of numbers, the area of this quarter second AOB is equal to 245.437 square meters in size. Okay, thank you very much.